Here, not in here. Alright guys, we have the bells turned off because I think they're doing makeup ACT testing today, so it's time for us to get started here. But welcome back. I hope you all had a nice break. Now it's been almost 2 full class days. It's almost hard to imagine that we just got back from spring break, but we did. So, reminder that before spring break, we did sections 1, 9, 3, 1, 3, 2. So mostly inverse, exponential, and the beginning of logarithmic stuff. And we had a 50-point test. So for the second half of that unit, we still have one more 50-point test. And we have to do 2 more sections, 3, 3, and 3, 4. 3, 3 will be today. It's just a one-day section. It's focusing on expanding and condensing logarithms, which hopefully is familiar to you from Algebra 2, because you certainly did it in Algebra 2. Can you shut that for me, please, Jackson? It's loud out there. But one thing that's a little bit different is we won't quiz each section individually. So we're going to spend one day on 3, 3. We'll spend a couple classes on 3, 4, and then we'll quiz both of them, review both of them, and then test both of them. So that is the plan. So our notes today start off with number 100. Finally made it to the 3 digits. Okay, and so let's start off with condensing logarithms. So condensing and expanding are really just opposites. So if you can condense, then in undoing it would be expanding. So it's really like one skill, but we need to go both directions. So if you'd look this up in the textbook, one thing that it would say is that if you have 2 logs of the same base, I'm just going to use a generic number A, you can condense them into a single log of base A. Make sure that these are different. And there's only 2 ways to condense. If there's a subtract sign between them, then you're going to condense with division. So B is part of the first logarithm, so it's the numerator. C is part of the second logarithm, so it's part of the denominator. But to actually apply this, it would look more like question 1. This is a log base 3, this is a log base 3, so you could condense them into a single log base 3. And since there is a subtract sign between there, you could condense them to 5 over 2. Subtraction between logarithms subtraction between logarithms condense into division inside of a logarithm. Okay, the only other way to condense, because there's only two of these, would be basically the same idea. You've got two logs of the same type, same base. You can condense those into a single log of that base. But if they are being separated by addition, you would condense them with multiplication. Now, one thing to be careful about, if this was multiplication between logarithms or division between logarithms, you could not condense to subtraction and addition. These are the two and only ways to condense. Subtraction and addition condenses to division and multiplication, but you don't condense division and subtraction. I only point that out because sometimes you guys do this. You'll just say, well, subtraction becomes division and addition becomes multiplication, but you still have to be careful about the direction. If this was multiplication, this wouldn't condense at all. If this was division, this would not condense at all. These are the only two ways to condense. But to use the second property on question 2, it's the log base 3 plus the log base 3, so we could condense them into a single log base 3. Since they were separated by addition, when we condense them, it would be with multiplication. So that is the same as log base 3 of 10. Now, once we're done with the notes, there is a book assignment, and the book assignment does have quite a few questions to it, but all of the questions are very quick, so it works out fast. And a few of them do a good job of showing you why you need to do this skill and not just practice doing it. But in our notes here, I have a couple that are a little bit off track, but I just want to show you one. I just want to convince you that this does something that is needed. So this question, again, I want you to do it for your notes, but this is not really considered part of section 3.3. This would be more like a 3.4 question. But if you're trying to solve for a variable like this, your options are pretty limited real fast. In fact, I'm going to say that you can't do anything, not even one step, unless you know how to condense. If you know how to condense and you recognize that you can condense, you could change this to log base 5 of 10x equals 2. And there's more to it, but at least if you know how to condense, you can fall back and do some of the other stuff we did before spring break, like switching logarithmic form into exponential form, undoing times with divide, and then of course, I guess, if it reduces, you should reduce. So again, we're not worried about solving equations in this section. I just want you to see, here's one example of where you can't do anything if you don't know how to condense. That's the only way to solve something like that. All right, and again, if you really understand condensing, then expanding is the exact opposite of that. So now it's like your answers become the questions and your questions become the answers. So if this is condensed with division, I could expand this with subtraction, just undoing what I did in question 1. And when you go to check some of your answers in the textbook, if it's something like this that comes out to a nice whole number, they're not going to leave it like this. Remember, this means 3 to what power gives you 3. So if it comes out to something that's a nice whole number like that, you should just go ahead and change it. Okay, or the only other way to expand or undo condensing is if they were condensed with multiplication, you could go back and expand them with addition. Just undoing what we did in question 3. And again, if some of this goes to a nice whole number, you should just make a habit out of doing that. But 2 ways to expand, undoing those 2 ways to condense. Okay, so again, not too important yet, although I guess you do have some questions like this in the book assignment. But I feel like this is a good one to bring back up because I felt like this would have been fair game to put on your test before spring break. And so the only way you could have done this before spring break would be with exponent properties. 7 to the negative fourth in the denominator is the same thing as 7 to the positive fourth in the numerator. And then since 4 is an exponent on something you're taking the log of, the 4 can come down. And then your answer comes from 4 times 1. There's nothing wrong with that. But if you can expand, you've got some options now. So when you get to your next test, this could be a question. You're still welcome to do it this way if you think it's easier. But I need you to see that your option is you could condense this instead. So that would be log base 7 of 1 minus log base 7 of 7 to the negative 4. Subtract, or division expands to subtraction. And then you can evaluate this. 7 to the 0 gives you 1. Over here, the negative 4 can come down. And then log base 7 of 7 would be 1. But I just want you to see that you get the same answer. Because for some of you, the expanding on the left is easier to follow than the exponent properties on the right. You still need to know exponent properties, you still need to be able to expand, but occasionally you can take your choice on whatever method you think makes more sense to you. Alright, so within that, yeah, what you got done?
How come it goes log base 7 of 1 minus log base 7 of 7, and then it just turns into a positive, like plus 4 times log?
Right here?
Yeah.
From here to here?
Subtraction go.
Oh, well, when I brought this down, the negative times the negative 4 made it a positive 4. Whenever you bring it down, if there was something already there, it gets multiplied. Any other questions on this side? Okay, so again, there's only 2 ways to expand, 2 ways to condense, but there's some stuff that kind of shows up, just some little things that we need to talk about on the back so that we're handling this stuff in a consistent and appropriate way. So if I asked you to condense this one on number 8, what I know you would do is you'd say, well, there's subtraction between these. So it's going to change to a log base 3. Subtraction becomes division. I'll try to highlight it like this for you every time to help you see that. 5 comes first, so it's the numerator. 2 comes second, so it's the denominator. The problem with this, and what you need to adjust in your thinking here, is I just skimmed past the fact that there's a 2 in front of this. I can't pretend like that 2 is not really there. For us to expand or condense, these coefficients, the number in front of the logs, really need to be a 1. So this is a 1. Well, actually it's a negative 1, but that's okay. 1 or negative 1's fine. But this 2, you can't pretend like it's not there. But what you can do is you can bring it back up. Usually with logarithms, if it's an exponent on something you're taking the log of, you bring it down. But in this case, you have to get that 2 up out of the way, bring it up as an exponent for number 7. Bring it up as an exponent, and then you can condense normally. But don't just pretend like the 2's not there and then hope that you put it in the right spot. Bring it up, get it out of the way, and then condense normally. Subtraction condenses to division. Yep.
So in this you want complex or improper fractions
Versus mixed numbers.
Yeah.
Yeah, I mean mixed numbers, like on the test, if you wrote this as 12 and 1/2, I mean I'm not going to count that wrong because it's correct, but 99.99% of the time in higher math, improper fractions are preferred. So, in fact, just yesterday, my calculus class does a little bit of Khan Academy assignments, and someone put in an answer as a mixed fraction and it didn't even take it. but the improper fraction was the correct answer. Even though they're equivalent, it wasn't smart enough to tell, so should always aim for improper fraction. But again, I wouldn't penalize you if you did it differently on the test as long as it was equivalent. Okay, so if you are condensing, at the start of the question, you need to bring the exponents up to get them out of the way. But if you're expanding, you need to fix that at the end of the questions. So what I mean by that is, if this said expand, you could have a log base 3 of 9 plus a log base 3 of x squared, because multiplication expands as addition. But then you go check your answer in the back of the book, and they're going to do one different thing here. When you're expanding, you really want those exponents to come back down as coefficients. So, well, first off, they would just change that to a 2, because 3 squared is 2. But over here, they're going to bring this 2 down. So if you're expanding, bring all the exponents down at the end. If you're condensing, bring the exponents, or bring the coefficients up as exponents at the beginning. Not the most important math thing, but again, you might think you're doing something wrong if you don't develop those habits. Okay, before I give you a couple other quick reminders, I know we've talked about the other two things a couple times. I do want you to try 2 quick questions, one expanding, one condensing, just to hopefully either give you some confidence there or help you to quickly pick out something you might have a mistake on. And I will tell you that question 12, most people don't get question 12 right. There's something a little bit different about 12, but I want you to have a chance to see if you can get it without me telling you. And also, it is a very common type of question. I have seen it on lots of ACT practice type stuff, so it's good to make sure that you don't fall into a certain trap here. So go ahead and just try those 2 the best that you can, please. go ahead and check here. So 11 really only had one thing that I'm concerned about. So if these two were separated by subtraction, you should have condensed them into division. Natural log is still going to be natural log. But the thing that I'm concerned about, and why I think this is a good practice question, is you can't ignore this 3 here. Don't hope that you just throw it in the right spot on your answer. This can come up as an exponent, just like it can come down. You can move it back and forth, whichever way makes sense. So the first thing was 3, so that's your numerator. The second thing was an x plus 1 cubed, so that should be your denominator. Bless you. We've condensed that into a single logarithm. So mainly just the 3. Make sure you bring it up as an exponent before you try to condense, and then it's no harder. But question 12 really has a couple different hurdles, and I'm less concerned about most of them, but there is one in particular. So this was division, so I can separate these with subtraction. I would say the first big hurdle was realizing that this expands further. Multiplication inside of a logarithm can expand as addition. I'm still also concerned that this isn't 100% correct, because going this direction, you should really bring down the exponents. You only bring them up if you're going the other direction to help you, but if you're going this direction, you should bring them down in the end. And what I have is still not correct.
You gotta subtract the 3 LNZ.
Right, so right here, this was minus all of this. When you expand it, it still has to be minus all of this. It's not just magically minus the first part of what you expanded and adding the second part. So you either need parentheses or you can distribute. So this last sign's not supposed to be a plus, it's supposed to be a minus. Again, the problem is when you expand this, it was minus all of this. So when you expand it, it's still minus all of it. Parentheses or distributing the negative is needed. I will also warn you, when I've seen this as an ACT question, they almost always, actually they may have always done it, put one of the answers as a plus here, because that's going to be the most common mistake. So, you guys okay with that? So, and you can see, having you practice it first, I bet most of you guys fell into that trap there. So I think you probably see why, but just be cautious of that. Okay, last two things. We talked about change of base before break, but it comes up in this section as well. In fact, I think the first like 4 or 5 book questions are just change of base. So change of base is a way that you can get your calculator to approximate a logarithm no matter what the base is. So they're asking us to show what the change of base would be with the common log. Common log just means base 10. So this is the same as log base 10 of 7 over log base 10 of 3. And part B, do the change of base with natural log. So you could do natural log of 7 over natural log of 3. You can type in either one of those two. Both of those are considered change of base. And then of course your calculator is going to give you 3, 4, 5, 6, 7, 8, 9 decimals worth of accuracy. So I knew that this would be between 1 and 2, but I couldn't begin to be that accurate with those decimals, certainly not that quickly. So again, this one's called common log. It uses base 10s. This one is change of base with natural logs. It's using base e's. But okay, and then finally, another just random algebra thing that comes up a lot in this section is you need to know how roots are written as exponents. So like square root should be thought of as an exponent of a half. cube root is like an exponent of a third. A fourth root is like an exponent of a fourth. And how this is going to show up, even when you don't expect it to, is this question could say expand. This is 7 times the square root of x, so you would expand with addition. But then you go check your answer in the back of the book, and your answer doesn't look like this, or their answer doesn't look like this. And the reason why their answer is going to look different is not that you did anything wrong to start off with, but the square root of x is like an the square root's like an exponent of a half. And then, because it's an exponent on something you're taking the log of and you're expanding, they're going to bring that down out front. So they're not going to have a square root on the x, and then they're going to have this 1/2. And that's where it's coming from. They're thinking of the square root as an exponent and then bringing it down with logarithm properties. So if you're not actively thinking of this, it will make a couple of the questions a little harder. Okay, any immediate questions? Anything you immediately would like some justification on from the notes? Okay, so if you didn't get out a piece of paper for the bell work, please go ahead and get that out, copy the assignment down. I'm going to check in with you guys 3 or 4 times during this class to help out with whatever's causing the most issues. Again, I know this looks like a lot of questions, but I would say the majority of these questions can be very quick, like 10-second, 20-second questions. So. So, to start off here, I'll do a quick 15-minute timer. So, copy the assignment down, try to do the first few questions over change of base, and then there's some questions that ask you to try to evaluate without a calculator. But when 15 minutes up, I'll give you your first chance to ask for certain ones to be worked out. And again, based on the only reason I do have this opened up in Google Classroom, so when you finish it up, I do encourage you to go ahead and just scan it and turn it in. It's technically not due by Thursday just because I saw how many questions it was and I forgot that the questions were so quick. So I didn't make my 8A classes have to have it finished by Wednesday, even though I think they do. So it'll be the same for y'all. I will ask for it later, but calculus thing.
What type of calculus things?
We figure out the volume of shapes that have curvature like that.
Really? How complicated is it?
Well, that's what we did today, actually.
So you found the volume of this shape.
Well, not that one exactly, but
This one.
there, like that. If you took that yellow highlighted area
Okay.
and you spin it around the x-axis, it makes a 3-dimensional shape.
Okay.
Well, this is the volume of that.
Okay.
But, I mean, you don't know what these symbols mean.
No, I have zero clue what that means.
That's what you learn in calculus. Mr. Johnson, how do I find the exact value of this? You just have to know how to read it. This is saying 3 to what power gives you 9.
Oh. Sorry. Oh, I'm sorry.
almost 15 minutes at least. All right, so what questions do we have? 1 and 2 vocab questions. 5 and 9 were about using the change of base formula. So any questions that you'd like me to go over from 1, 2, 5, or 9? Yeah.
What's number 2?
Number 2. Number 2 is saying if you did change of base for this, well, you could either do common log or natural log. But they're saying the change of base formula for base E. So natural log's the one that's base E. So they are wanting this one. Mhm. Okay, any others? 1, 2, 5, or 9? Yeah. Number 5. Okay, so write this as the common logs. So that's where you would do log base 10, change of base. And then part B with natural logs, that would be change of base with natural logs. So part A answer, part B answer. Change of base, they're just asking you to write it both ways. Okay, the next little group, I'm sure not everyone has finished all of those, but 19 through 32 are all achievable without a calculator. So is there any questions 19 through 32 that you've tried and you know you need to ask about? We can just go ahead and get them done.
23.
Sorry, which one?
23.
23? Okay, so remember what this one's asking. Bless you. This is saying 2 to what power, here's your answer, gives you -2. And you should struggle with this because this is not possible. There's 2 ways that you can know that this is, well, 3 ways that you can know this is not possible. You can try to answer this question all day until you realize that you can't think of anything that makes this happen. Or you could think about what log base 2 of x looks like as a graph, because it reminds you that you can't take the log of 0 and you can't take the log of a negative number. When x is -2, it doesn't exist. That's why it doesn't make sense. And 3, when we talked about extraneous solutions before break, I said you can have 0 as an answer, you can have a negative number as an answer, but when we plugged in our answers to check to make sure they weren't extraneous, we had to plug them in and make sure that we're not taking the log of 0 or the log of a negative, because that doesn't make sense. So, bless you.
Thank you.
And then same with 24. Can't take the log of a negative number, so, or 0, so not possible. Okay, others 19 through 32.
Can you do 21?
Sure. Okay, this one you could actually go about this a few different ways, but I think probably the best start would be to just change this cube root to an exponent, like we talked about at the end of the notes. Because then as soon as it's an exponent on something you're taking the log of, the exponent can come down out front. And then so your answer comes from 1/3 times this. Are you okay with what this equals? Okay. So 6 to the first gives you 6. If you want the reciprocal of that, you would want 6 to the -1. The other thing you could do here is you could expand this. That would be a lot of work, I think, but the main thing is just deal with that cube root by changing it to an exponent and bringing it down, and then it's a little more familiar. And I would pretty much always do that. Like question 22 has that 4th root, I would probably change that to an exponent of the 4th to start off. Okay, others 19 through 32. John, was that yours?
Those ones.
That was yours. Okay. Okay. Let me set another 15-minute timer. So, of course, don't give up on a question right away. But if you get hard stuck, put a star by it and be ready to ask when I take more questions. Of course, just like I always suggested before the break, as you guys get to questions like these, that they have something to them that was not intuitive to you, you probably should star them anyway, because those would be the questions you might want to look at before your quiz. That would be very efficient studying to approach it that way.
There's a multiplication. You're multiplying one times two combined. That just doesn't seem like something that one
Negative 1/8.
Okay, about 5 more minutes, and I'll take another round of questions on the board.
It's just have you looked at 60? Because that one is like an easier.
Oh, wait, no, it would be-
Natural log would be, you see how maybe natural log. Natural log would be zero. So
Unless you're going for like
x to 0.
No, wait, natural log would be-
Natural log of 1 is away. That
So
is
it's
a way to get the same answer.
7?
It's a better way of doing it. Because you can just apply the x squared. Because when you, or the x squared, because when you apply the square root of the x squared, it just turns into x. And then you have the square root of x equals 2.
It's not 0.
And that's okay. You can just take the 1/2 out. So, so for 60, this might be slightly better. But that's the same as ln(x) times times that one. It's just the constant whole thing. And let's go these apart.
Which one is that? 27 is 7. That's what I got.
But this was, because now 1/4 implies that both of them, right? So we just take that out.
missed it. All right, it's been almost 16 minutes, so. All right, I think I already took your questions 1, 2, 5, and 9, but if you still have questions from those, that's fine. Anything 19 through 32, maybe 41, 43, or 59, any of that kind of stuff. Yeah.
26.
26. All right, 26 we could do two different ways that I think are both probably about equal, so I'll show you both just in case. One thing to do would be to think of the square root as an exponent of a half, and then if you want to use exponent rules, e to the positive 1/2 in the denominator is the same thing as e to the negative 1/2 in the numerator. Now the negative 1/2 is an exponent on something we're taking the log of. And then what about this part? Do you remember what natural log of e is?
It cancels that. 1. Or 1.
Yeah, it's 1, because it's saying e to what power gives you e. So your answer comes from negative 1/2 times 1. Or your option is, if you prefer to do the expanding way, you could say natural log of 1 minus the natural log of the square root of e. This becomes 0. E to the 0 gives you 1. This one, you would still want to change the square root into an exponent. Bring the exponent down, and then you can see it's basically the same work. So, just whatever you think's easier. But on the right, it's taken like a exponent rule approach, and on the left, it's taken an expanding approach. Of course, on the test, if you had time, it wouldn't be a bad idea to just do it both ways and make sure you got the same answer both ways. But all right, John, what'd you have?
31.
31. Okay, I'm also going to look at this one two different ways, although I'll have to kind of wing the second way, but I never actually thought of a second way until yesterday. But to me, this is like questions we did in section 3.2. I know, just glancing at this, the answer has to be bigger than 1 because that only gives me 4, and it has to be less than 2 because that gives me 16. I'm trying to get 8. The fact that the answer is between 1 and 2 tells me that it has to be a fraction. So what I suggested to you in section 3.2 was make yourself do it over 2 steps. So we're going to raise 4 to something to get it to be a different number, and then we're going to raise that to something to get to 8. So we first want to make this lower. We want to lower this base a little bit. So you need to be thinking square roots, cube roots, fourth roots, really anything that's going to make this go into this evenly. So in this case, it would be square root, because the square root of 4 is 2. And then now that I've rephrased the question, 2 to what power gives you 8?
3.
Okay, so you really want to square root it and cube it, and to do both at the same time would be raising it to the 3 over 2, which of course is between 1 and 2. So that's how I would have told you to do it in section 3.2, and that's perfectly fine. But yesterday I thought I was just trying to relate it to this stuff a little bit more. I did think of a creative way that you could go about this differently, and what I was trying to think of, and I don't know if I can do it on the fly, but if I can think of 2 numbers that multiply to 8 or to divide to 8, you could do something like this. If I changed 8 to be like 4 times 2, these are the same thing, right? Then you could say, well, what if I expanded this? This would be log base 4 of 4 plus log base 4 of 2. And again, this is a little hard because you kind of have to find 2 numbers that multiply to 8 where both of these are going to come out nice too. But this is obviously 1. What exponent of 4 gives you 2?
1/2.
And so you could also get 3 over 2 that way. But again, you got to think of a creative way to rewrite 8 such that after you expand it, it gives you 2 things that you could find. So, but if you think that's easier, then you can take that approach too. Yeah,
We do 28.
sure. Okay, so what do you think we should do with this 5 over here?
Put it in front of the natural log.
Okay, so since it's an exponent on something, you're taking the log up, it can be brought down out front. So shouldn't we do the same thing with 6 then?
Yes, but you just multiply to 2.
So that makes it 12. It's like 2 times whatever that stuff is, and that stuff was 6 natural log of e, so in the end it's 12 natural log of e.
Okay, so it's okay. It's to be 12 minus 5 is 7, right?
Correct. Natural log of e is still 1. All right, others that you have ready to go? Yeah. 43. Let's see, 43 asks us to expand, and honestly there's not much that you can do here, because this is x to the 4th, not times anything, not divided by anything. So I would say the only thing that you can do is write your answer in the form that it wants. And by that I mean when you're expanding, they expect you to bring this down at the end. So I would expect the back of the book to just look like that. I don't know that I really consider that expanding, but again, that's part of how they want you to write your answers. So yeah, hey, 59. So a couple of the last questions, and 59 is kind of the first place where it kind of dips its toes into this. It's going to be the same skills. There's still going to be 2 ways to expand, 2 ways to condense, all that kind of stuff. But some of the last questions do get a little bit messier and a little more intimidating, but they should be the same thing. So when I look at this, just like I started question 21 and 22, I would change the 4th root to an exponent of a 4th, because now it's an exponent on something I'm taking the log of, so I can bring it down and I don't have to worry about that anymore. And then really there's only one more thing you can even do. This is x cubed times x squared plus 3. So this is 1/4 times all of this. So make sure you have parentheses. But to expand multiplication, you would need to expand it with addition. If it started off as natural logs, it's still going to be natural logs. And I guess actually there's one other thing we should do. Since we're expanding the exponents, this exponent of 3 should come down. And I guess if you just really want to distribute the 1/4, you can, but that's not considered more simplified. So
Would you have to split apart the ln x squared plus 3?
you can't split apart the ln x squared plus 3, and that's something y'all need to be really careful about. This is where I was trying to say at the beginning of our notes. If you oversimplify these 2 rules, where you just tell yourself addition goes with multiplication and subtraction goes with division, there's going to be times like this that you think you can go further. You cannot expand addition. You can condense addition, but you can't expand addition. You can expand multiplication or division. You can condense addition or subtraction, but you can't expand subtraction or addition, and you couldn't condense. I don't know, I lost track, but y'all get the point. It's 2 things, they work backwards, but you need to be careful when I say that, because it doesn't work backwards for both rules in both directions. Yeah.
Did we already go over 31?
Yes, we did. I'll put it back up while I wait for another question, though.
Appreciate it.
Okay, they already got more questions, so. You first.
74.
Can I do 74? Yeah. You want me to work it out on the board? Now, I know some of you are not quite to 74 yet, so as always, you can either jump ahead, or you could watch the class recording later, or I do have these worked out as individual videos too. So this is what I was mentioning a moment ago, a couple minutes ago, about at the end of these, the last maybe 2 to 3 questions are pretty intimidating, but they're the exact same skills. So first thing I would do here is just distribute a 2 to all 3 of these. Nothing really special about that step. Now, of course, if you're trying to do too much in one step, then that's a problem in itself. I know to condense, I need these to go up as exponents. The coefficients of the logs need to be 1. I could condense these 2 in one step. Logarithms separated by subtraction can condense with division. And honestly, I probably would just throw this in the mix in the same step, but I'm just trying to paste it out so that you can see. You okay with, I just condensed these 2? Okay. And then I need to condense these 2. They're both natural logs, so they're going to condense to a natural log. Subtraction is going to condense with division. Now, on this part, I guess one thing you do need to be careful about is you need to put some thought into, if you take this fraction and divide by this fraction, whether this stuff goes in the numerator or the denominator. And I would say the safest bet for that is to just give yourself a quick example to the right. If I take a fraction and try to divide it by something else, that's the same thing as multiplying by the reciprocal. So that actually goes to the denominator, not the numerator. If you divide a fraction by something, you're making the denominator bigger because you're making the overall thing smaller. Okay, so again, kind of scary question, but when you look at the steps, I distributed a 2 for step 1, nothing new. Got the exponents out of the way in step 2 so I could condense. I condensed subtraction to division, and then I condensed subtraction to division the second time. So nothing that you hadn't already practiced a lot, but again, you kind of have to just get over the fear factor of it just looks like it's going to be much more challenging. Yeah. Sure. Let me reset this. Let me make sure I get this too. So 70 is kind of along the same lines. We've got a bunch of parts. And they want us to condense. So just like I said in the last question, if you're going to condense, don't pretend like the 3, 1/4, and 4 are not there. Bring them up as exponents, get them out of the way. That should be your first step. Then, I think you could maybe even do this in one step now, but I'm going to just condense these 2. Since they're separated with addition, they would condense with multiplication. And I'll just carry this down. And then I can condense one more time because these are both the same type of log, log base 3. Subtraction condenses to division. The first log part becomes your numerator, and the second log part becomes your denominator. Now, of course, I haven't really mentioned this, but notice that I didn't try to bring the 3 down, I didn't try to bring the 1/4 down, I didn't try to bring the 4 down in the end, because part of that log was cubed, part of the log was raised to the 4th, part of the log was raised to the 1/4, but it wasn't the whole thing that I was taking the log of, so you can't bring any of those exponents down. Yeah.
Can you do 63?
63?
64?
64. Yeah, 64 is not a bad one, but again, it's kind of hard to know what they're even asking you to do there. The directions ask us to condense into a log of a single quantity. So there's kind of a hint in the directions here. When it says a log of a single quantity, your answer should be some kind of log of something. This is the format of your answer, the log of a single quantity. So really the only thing that you can do in this question, because there's nothing else to condense, but you can bring this up as an exponent. And now it's the log of a single quantity.
That's
So-
what I did. I just wasn't sure if we have to do something because that explains it.
I mean, I guess if you really wanted to, again, to me this isn't better, but I guess maybe in calculus there could be a time where maybe you would just want to move that whole thing to the denominator to make the exponent positive, but to me this is just as good, so. Yes,
72.
72. Okay, so same thing. This one's going to take a few steps, but I think if we break it into 3 to 4 steps, it shouldn't be much different. So I would take one step and distribute the 4. Has nothing to do with logarithms, but it gets rid of one set of. You guys know what the difference between parentheses and brackets are? I guess there are some differences in math, like matrices we use brackets instead of parentheses. Well, actually, that's not always the case. But in these instances, they mean the same thing. So, yeah.
With brackets and after the z plus 5.
Oh, good catch. And that makes a difference because that means that 4 is not being distributed there. Thank you. Okay, so I distributed the 4. I know that if I'm going to condense, I need this stuff to come up, out of the way. And then just to play it safe, I'll condense these 2 in one step. Since they were separated by addition, you could condense those with multiplication. And I'll just carry this down. And then to condense subtraction, I could condense those with division. So this stuff comes first. It's going to be in the numerator. This stuff comes second. It's going to be in the denominator. So again, another one that looks pretty scary, but at the end of the day, I distributed. I brought up the exponents out of the way. I condensed addition into multiplication. And I condensed subtraction into division. So same old stuff.
Wouldn't it be a power to the second at the bottom?
Yes, this is supposed to be a 2, so this should be a 2. Thank you. A lot of times when I get near the end of a long question, I kind of
Also,
coast a little bit.
couldn't you take the 4s at the top and turn them into a 2, and then you take the 2 at the bottom and turn them into a 1?
These 4s
Yeah.
and try to combine it with these?
Yeah.
No, I don't think so, because remember, z minus 5 squared means like z minus 5 times a z minus 5. Z plus 5 to the 4th means you have 4 of these. This is just a very inefficient way to write it. But you can see these things, and z to the 4th is like 4 z's. None of this stuff cancels out any of that stuff. Nothing's going to reduce there. They're different things. Now, if this was like a z plus 5 squared in the denominator, if this was a plus, these would be pluses, and then sure, then you could cancel out a couple of those, right? Then this could cancel out a couple of those, but those aren't the same thing, so you can't cancel those.
I was just thinking you could do z times z plus 5 over z minus 5, and then take that whole thing and square it. Or z squared times z plus 5 squared divided by z minus 5, and square that whole thing.
Okay, you gotta say that again. I can't think that quickly.
So ln of z squared times z plus 5 squared,
Okay.
and then divide by...
What
z
happened to the fourths, though?
Well, you're going to be squaring the whole thing at the end, but you can bring the 2 out to the front.
Oh, you mean like extracting?
Yeah.
Okay, you could do that, but that's not considered more simplified, so
Okay.
I don't, that just, you're signing yourself up for more work. But yeah, I guess in theory, you could pull a 2 out of all of that, and then these are the same thing. That's true. Sorry, I just misunderstood you the first time.
My bad.
Okay, if y'all have more questions ready, certainly can take more. I know we answered most of the end questions, so. All right. So you guys still have about 17 minutes, I think. So if you're not quite finished, go ahead and keep on going. Again, based on your grade, this homework assignment does not have to be turned in by the start of next class. I only did that because I thought it would take a little bit longer than it did. I didn't realize some of those questions were so quick until I reworked it this year. But I still think you should probably go ahead and scan it and turn it in the Google Classroom if you have it done. If you do find a question in the next 17 minutes, of course I'm happy to help. Just bring it up here and we can go over it together.
Appreciate it.